For 16 million years, a diverse group of reptiles dominated Earth's biosphere. They had evolved to thrive in a lush, complex world until a single piece of space rock erased their lineage in a matter of hours. 66 million years ago, the supercontinent Pangaea was pulling apart. North and South America had separated, and the outlines of Europe and Asia were beginning to take shape. The global climate was cooling, allowing ice caps to form at the poles, though the climate remained significantly warmer than it is today. This warmth supported dense green vegetation across the drifting continents. During this period, flowering plants emerged, and insects like bees and butterflies evolved to pollinate them. This produced seeded fruits, creating a rich food source that supported a boom in both herbivorous dinosaurs and early small mammals. The skeletal structure of the Tyrannosaurus rex reveals how these creatures occupied the top tier of the food chain. Their biological, specialized features allowed them to hunt, consume, and multiply across every continent on the globe for millions of years. Natural selection had refined these animals into specialized biological machines. They were so well integrated into their environment that they faced no internal pressure to change. They were optimized for a world that was about to vanish. 5 hours before the impact, there were no warning signs. It was an ordinary day. Across the globe, millions of animals spent their time foraging, hunting, and defending territory. In North America, a herd of 50 Alamosaurus migrated toward the Yucatán Peninsula. These creatures stood 29 meters tall and weighed 38 tons. To maintain that body mass, a single adult had to consume over a ton of fresh vegetation daily, forcing them into a nomadic existence. Hundreds of miles away, a 6.8-ton Tyrannosaurus rex defended its territory. A smaller 1.8-ton Carnotaurus had wandered into its hunting grounds, triggering a fight over resources that the smaller predator was unlikely to win. The T-Rex possessed binocular vision, allowing its eyes to create a single, precise visual image to judge distance. Combined with a sense of smell that could track prey from miles away, it was a lethal hunter, requiring 100 kilograms of meat daily just to survive. These extreme daily caloric requirements, a ton of leaves for the Alamosaurus, 100 kilos of meat for the T-Rex, were successful traits during the Cretaceous. But an animal that requires massive amounts of food to survive becomes vulnerable the moment that food supply is interrupted. 10 minutes before impact, a rock measuring 10 kilometers across breached the Earth's atmosphere. At 20 kilometers per second, it compressed the air in front of it, generating heat that made it shine brighter than the sun. Atmospheric friction created a flash of thermal energy intense enough to blind animals on the ground. The heat radiating off the falling rock scorched dinosaur skin and ignited dry vegetation before the asteroid even made contact with the surface. This satellite map shows the Yucatán Peninsula. Near the northern coast, the asteroid slammed into the Earth's crust with the energy of 10 billion atomic bombs, driving 20 kilometers into the bedrock in a single second. The thermal radiation pulse vaporized everything in the immediate vicinity. The Alamosaurus herd grazing nearby was incinerated by a wall of heat, reducing thousands of tons of bone and muscle to ash instantly. The kinetic strike served as the initial trigger, but the planet's violent physical response converted a regional disaster into a global catastrophe. The strike itself was only the beginning of a massive chain reaction. Immediately following the strike, a supersonic shockwave ripped across the landscape. The pressure wave was intense enough to strip the foliage off trees and throw multi-ton predators into the air, killing them before they even hit the ground. Kinetic force transferred into the ocean, displacing billions of gallons of water. This triggered tsunamis reaching 100 meters high. These waves surged thousands of miles inland, drowning coastal ecosystems and flooding the majority of the North American interior. The strike triggered magnitude 11.2 earthquakes, roughly 50 times more powerful than the largest recorded earthquake in history. The planet shook with such force that dormant volcanoes across the globe began to erupt simultaneously. At the impact zone, 15 trillion tons of vaporized rock were blasted into the sky. As this material cooled in the upper atmosphere, it condensed into burning boulders and glass-like shards. This debris rained back down, pummeling the survivors in a global firestorm. You can see the record of this day in sedimentary rock. This dark line is the KPG boundary. It contains high concentrations of iridium, a metal rare on Earth but common in asteroids. This worldwide layer provides a timestamp of the day the debris settled. In a few hours, the vibrant environment of the Cretaceous was destroyed. The surface of the planet had transitioned from a thriving forest to a burning, toxic wasteland. Volcanic eruptions and the impact site ejected 70 billion tons of pulverized stone, soot, and carbon monoxide. This cloud expanded at 18,000 kilometers per hour, shrouding the entire planet in a blanket that blocked all incoming sunlight. Sulfur compounds mixed with moisture in the troposphere. For weeks, the skies rained concentrated sulfuric acid. This toxic downpour poisoned the topsoil and water systems, destroying whatever surface plant life remained after the fires. With no sunlight, global temperatures dropped by as much as 28 degrees Celsius. The Earth entered an impact winter, where the only widespread living organisms were decaying fungi and molds, feeding off the dead landscape. This caused a total collapse of the food chain. Large dinosaurs that survived the initial blast emerged to find no vegetation and no prey. Starvation claimed those who had survived the heat, the tsunamis, and the earthquakes. Size and strength offered no protection against a freezing climate and a broken atmosphere. The traits that once ensured dominance were now liabilities in a world that had ceased to produce calories. While the large reptiles starved, a different class of animals weathered the storm. Small early mammals, insects, and certain avian species survived by sheltering in burrows or inside hollowed trees. As the fires died down and the acid rain slowed, these small mammals emerged into a shattered world. They found a landscape devoid of massive predators, allowing them to scavenge for survival without the threat of being hunted. Their survival was a matter of biology. Because they were small, they had low caloric requirements. They subsisted on buried seeds, dead insects, and decaying material, outlasting the famine that ended the dinosaur lineage. Over decades, the ash clouds dissipated. As sunlight returned, plants began to grow again. The surviving mammals, already adapted to extreme conditions, multiplied and evolved to fill the roles left vacant by the extinct giants. This lineage eventually led to the rise of humans. Our species has existed for only a few million years, a fraction of the dinosaurs' 160 million year history. Their sudden end serves as a reminder of how quickly an established group of organisms can be removed from the planet.